Close your eyes, if you'd like, or let them grow heavy as you gaze at the stars that are about to appear before you, because what we are going to explore tonight is perhaps the most breathtaking structure that has ever been discovered, a structure so vast, so ancient, and so impossibly beautiful that even the scientists who study it find themselves pausing in quiet wonder, unable to speak for a moment, simply staring, and breathing, and feeling something they struggle to name. We are going to journey through the cosmic web. And we are going to see it, truly see it, the way it has never been seen before, through the eyes of the James Webb Space Telescope, in the year 2026, when humanity finally gathered enough light from the deepest corners of the observable universe to begin to understand the skeleton of everything that exists. Let yourself settle now, feel the weight of your body against whatever surface holds you, notice the gentle rise and fall of your chest, and know that you are about to travel further than any human being has ever physically traveled, not with your body, but with your mind, and with the light that has been patiently crossing the universe for billions upon billions of years, just to reach the mirrors of a golden telescope floating in the cold silence of space, and then, to reach you. The universe is not empty, and this is the first thing to understand as we begin, the first soft truth to let settle into your mind like a stone sinking slowly through still, dark water. For centuries, when we looked up at the night sky, we saw points of light scattered seemingly at random, stars here, a cluster there, a smudge of distant light that we eventually understood was another galaxy entirely, billions of stars gathered together in their own great spiral or elliptical form, drifting through the dark. And it seemed, for a very long time, that these galaxies were simply scattered randomly through space, like dust motes floating in a sunbeam, beautiful, yes, but without pattern, without deeper structure, without meaning beyond their individual existence. But the universe had been hiding something from us, something magnificent, something that required instruments of extraordinary sensitivity and extraordinary patience to finally reveal. The cosmic web is a structure that spans the entire observable universe, a vast, intricate, almost impossibly delicate network of filaments and nodes and voids that organizes every galaxy, every cluster of galaxies, every wisp of gas and dark matter, into a pattern so coherent and so beautiful that when scientists first saw simulations of it in the late 20th century, they stopped and stared, and some of them, quietly, felt something they had not expected to feel in a physics seminar. They felt awe, genuine, overwhelming, childlike awe. Imagine, if you will, the most intricate spiderweb you have ever seen, glistening with morning dew, each thread connecting to the next, each droplet of water sitting at the intersection of multiple strands, catching the light, refracting it into tiny private rainbows. Now imagine that spiderweb expanding in 3 dimensions in every direction, not flat, not two-dimensional, but volumetric, a 3-dimensional lacework of unimaginable scale, and instead of a spider's silk, the threads are made of dark matter and hydrogen gas and countless billions of galaxies, and instead of droplets of dew, the nodes where threads intersect are home to the most massive galaxy clusters in the known universe. Titanic gatherings of thousands of galaxies, vast reservoirs of hot plasma, places where matter has accumulated over billions of years of slow gravitational coaxing. Let that image settle in your mind, let it breathe, let it expand. This is the cosmic web. And for decades, we had only glimpsed it, only suspected its full extent, only traced its outline with the tools available to us, like someone trying to understand a great painting by touching it in the dark with just one fingertip. The tools that came before were remarkable in their own right, and we should honor them, because without them, we would never have known where to look. The 2-degree field galaxy redshift survey, the Sloan Digital Sky Survey, great projects that mapped hundreds of thousands and then millions of galaxies, plotting their positions in 3-dimensional space by measuring the way their light was stretched by the expansion of the universe, a phenomenon we call redshift. The light from distant galaxies shifted toward the red end of the spectrum, the longer wavelengths, as space itself stretches between us and them during the billions of years that light takes to travel. And when those galaxy positions were plotted, the pattern emerged, unmistakably, magnificently, filaments of galaxies snaking across the charts, vast empty regions called voids, sitting between the filaments like bubbles in a foam. And at the intersections of filaments, the great clusters, glowing bright in the data. But these surveys were working primarily in visible light, and they were working, for the most part, with galaxies in our cosmological neighborhood, the relatively recent universe, galaxies as they appeared a few billion years ago, or at most, perhaps 8 or 9 billion years ago. They were like archaeologists who had found the ruins of a civilization but had only excavated the top few layers, only seen the most recent period of habitation, not yet reached the foundations, not yet understood when and how the city was first built. To see the cosmic web in its youth, to watch it forming, to observe the very early universe as the first structures were assembling themselves out of the primordial quantum fluctuations, the tiny ripples in the density of matter that were imprinted in the first fraction of a second after the Big Bang, and which, over hundreds of millions and then billions of years, grew, slowly and inexorably, under the patient pull of gravity, into the great scaffolding of everything we see. Today, to witness that process, even indirectly, required something extraordinary. It required the James Webb Space Telescope. And now, as you let your breathing slow, as the world outside this moment grows a little quieter and a little further away, we are going to step into what this telescope has revealed, because in 2026, the data that had been accumulating since the telescope began its science operations in 2022 reached a new threshold of depth and completeness, a threshold beyond which the universe's deepest structures began to emerge with a clarity that left even veteran cosmologists standing at their computer screens in a kind of reverent silence. The James Webb Space Telescope was launched on Christmas Day, 2021. A gift, in its way, to all of humanity, carried aloft by an Ariane 5 rocket from the Guiana Space Center in Kourou, French Guiana, and then sent on a month-long journey to its operational home at a gravitationally stable point in space called the Second Lagrange Point, or L2, approximately 1.5 million kilometers from Earth, always on the night side, always looking away from the sun. Perfectly positioned to gaze into the cold, dark depths of the ancient universe. The telescope itself is a marvel of engineering that borders on the poetic. Its primary mirror is nearly 6.5 meters across, the honeycomb of 18 hexagonal golden segments coated with an extraordinarily thin layer of pure gold, just enough gold to optimize the reflection of the infrared light that the telescope was designed to detect. Because the most distant objects in the universe, the galaxies of the early cosmic web, are so far away, and the universe has been expanding so long, that their light has been stretched far beyond the visible range, stretched into the infrared, the warm, invisible glow of heat and deep time. And to see that light, the telescope needed to be cold, extraordinarily cold, shielded from the warmth of the sun and the earth and even its own electronics by a sunshield the size of a tennis court, a 5-layer structure of reflective material that keeps the mirror and instruments at a temperature near -233 degrees Celsius, just 40 degrees above absolute zero, the coldest possible temperature in the universe, the temperature at which all thermal motion ceases. In that profound cold, in that perfect stillness of temperature, the telescope gathers light, patiently, photon by photon, building up images over hours and days of continuous exposure. And those images, those accumulations of ancient light, began to reveal the cosmic web in a way that no instrument before had managed. Let yourself sink a little deeper now, feel the surface beneath you receiving your weight completely. There is nothing you need to do, nowhere you need to be, you are simply here, held gently, drifting through the universe with the soft guidance of ancient light. The cosmic web, as Webb began to reveal it, is not a static thing, and this is one of the most profound and beautiful things about it. It is a living structure, or at least, something as close to living as physics allows. It evolves, it grows, it changes over time, and because the speed of light is finite, because it takes light time to travel across the universe, looking out into deep space is the same as looking back in time. When Webb observes a galaxy whose light has traveled for 13 billion years to reach us, it is not seeing that galaxy as it exists today, it is seeing that galaxy as it existed 13 billion years ago, when the universe was less than 1 billion years old, when everything was young and chaotic and bright and hot with the energy of recent creation. This is the gift that distance gives us. It's a window into history, a natural time machine built into the very physics of light and space. And the cosmic web, being the largest structure in the universe, is visible across all of these cosmic epochs if only we have the instrument sensitive enough to trace its outline in the deep dark of the ancient sky. In the years following its first science operations, Webb began to find something that cosmologists had predicted but never directly confirmed at such early cosmic times. It began to find filaments, gossamer threads of galaxies and gas connecting the first great overdensities of matter in the universe, structures that were already organizing themselves into recognizable nodes and filaments when the universe was only a few 100 million years old, far earlier than many models had predicted. And the implications of this early appearance were profound, and in some cases, gently unsettling to the existing frameworks of our understanding. Because the cosmic web is not just a description of where galaxies happen to be, it is a fundamental consequence of the way matter and energy were distributed in the first moments after the Big Bang. The quantum fluctuations in the density of the early universe, tiny variations, some regions infinitesimally denser than others, were frozen in place when the universe cooled through a phase transition in its earliest fraction of a second, and from that moment forward, gravity began its patient work. Matter fell toward the denser regions, those regions grew denser still, and as they grew, their gravitational influence extended further, drawing in more matter from wider and wider regions. The less dense regions were left behind, growing emptier and emptier as matter drained away toward the growing filaments and nodes, becoming the great voids that define the negative space of the cosmic web, the dark silence between the glowing threads. This process is called gravitational collapse, and it is both extraordinarily slow and utterly relentless. Over hundreds of millions of years, the first filaments formed sheets of matter that intersected in lines, and where lines intersected, points, and at those points, matter accumulated in extraordinary concentrations, becoming the first galaxies, blazing with the light of massive young stars living their brief, brilliant lives and dying in spectacular supernovae, seeding the surrounding gas with the first heavy elements, carbon, oxygen, iron, silicon, the building blocks that would eventually, billions of years later, find their way into planets and into you. You are, in the most literal and profound sense, a product of the cosmic web. The carbon in your cells was forged in the hearts of stars that lived and died in the early filaments of this vast structure. The oxygen you are breathing right now was scattered through the interstellar medium by stellar winds and supernova explosions that occurred along the threads of the web billions of years before our solar system existed. You are not separate from the cosmic web, you are a local expression of it, a temporary, beautiful, conscious complexity that has emerged from the same primordial fluctuations that built the largest structure in the observable universe. Let that thought rest with you gently. There is no need to grasp it fully, just let it be present, like a warm light in the room. In 2026, the Webb telescope's extended deep field surveys had accumulated enough observational data to do something remarkable, to produce what researchers called a tomographic map of the cosmic web, a three-dimensional reconstruction of the large-scale structure of the universe across multiple cosmic epochs, from the present back to within the first billion years of cosmic history. This was not a single image but a synthesis of thousands of observations, each one a window into a slightly different distance and therefore a slightly different time, assembled together like layers of a geological core sample, each layer telling the story of a different era in the universe's long history. And what that map revealed was continuity. The cosmic web that exists today, the vast network that was mapped by ground-based surveys in the late 20th and early 21st centuries, could be traced backward in time, its filaments growing thinner and more tenuous as we looked earlier and earlier in cosmic history, but always present, always recognizable, always maintaining the essential character of the structure that was destined to emerge from those quantum seeds planted in the first instant of creation. There is something deeply moving about this continuity, about the fact that the large-scale structure of the universe today is, in its essential form, the inevitable destiny of those first infinitesimal fluctuations, as if the universe, at its very beginning, already contained within it a kind of blueprint, a vast, invisible plan written in the language of quantum mechanics and gravity, that would slowly, patiently, over the course of billions of years, reveal itself as this magnificent web of light and matter that spans everything we can see. Let your mind drift with that thought, let it carry you gently, the universe patient, purposeful in its physics, beautiful in its mathematics. One of the most striking features of the cosmic web as revealed by Webb's deep observations is the nature of the filaments themselves. These are not simply highways of galaxies, they are dynamic environments, rivers of matter flowing toward the great nodes at their intersections. The gas that fills the filaments, the intergalactic medium, as scientists call it, is not static but in constant motion, pulled by gravity toward the growing clusters at the nodes, shaped by the radiation from billions of galaxies embedded along the threads, heated and cooled and heated again in a continuous cycle of energetic exchange. The filaments glow, though not in visible light. They emit a faint whisper of ultraviolet radiation, the signature of hydrogen gas that has been ionized by the intense ultraviolet light pouring from the galaxies within and around them. This emission, called Lyman alpha radiation, has been a critical tool for tracing the cosmic web at high redshifts, at great cosmic distances and therefore great cosmic ages. And Webb's instruments, particularly its near-infrared spectrograph, have been gathering the redshifted versions of this emission, stretched from ultraviolet into near-infrared by the expansion of the universe, building up a picture of the web's filamentary structure in the early universe with an unprecedented richness of detail. What the data shows is a web that was already surprisingly well organized at early times. The filaments at redshift 6, when the universe was less than a billion years old, are thinner and less massive than their modern counterparts, but they are unmistakably there, connecting clusters of galaxies, funneling gas and matter toward the growing nodes, already doing the work that will eventually produce the great clusters that dominate the modern universe. And the galaxies that live within these early filaments, they are extraordinary objects, bright, turbulent, forming stars at rates that would be impossible in the more settled galaxies of the present universe. They burn through their gas rapidly, like candles lit at both ends, forming stars hundreds or even thousands of times faster than our own Milky Way does today. They are the factories of the early universe, the blazing furnaces in which the first heavy elements were created and distributed through the intergalactic medium. And they are arranged, even at this early epoch, along the filaments of the web, their positions telling the story of the gravitational structure that has organized them. As you settle deeper into rest, let the image of these early galaxies come gently to mind, bright points of ancient light, strung along filaments of gas and dark matter like luminous beads on an invisible thread, burning through the darkness of the young universe, and drifting, slowly, inexorably, toward one another along the gravitational currents of the web. Now, we should speak of the dark, because we cannot speak of the cosmic web honestly without speaking of dark matter and dark energy, those two mysterious components that together make up approximately 95% of everything the universe contains, and which, despite their dominance, remain among the deepest mysteries in all of science. Dark matter is the scaffolding on which the cosmic web is built. It is a form of matter that does not interact with light in any way we can directly detect. It does not emit light, it does not absorb light, it does not reflect light. It is genuinely, profoundly dark. And yet, it has mass, and therefore it has gravity, and through gravity, it shapes everything. The cosmic web, in its truest form, is first and foremost a web of dark matter. The galaxies and gas that we can observe are concentrated along the filaments and nodes of this dark matter web, drawn there by gravity, but they are, in a sense, merely traces, indicators of where the invisible dark matter skeleton lies, like foam on the surface of a deep, dark ocean, marking the patterns of currents we cannot directly see. The existence of dark matter was inferred long before the cosmic web was mapped. The rotation curves of galaxies, the gravitational lensing of light around galaxy clusters, the cosmic microwave background, all of these observations pointed inescapably to the conclusion that the universe contains far more mass than the matter we can see, roughly 5 times as much dark matter as ordinary matter. And without that dark matter, the cosmic web could not exist in the form we observe. The gravitational pull of ordinary matter alone would not have been sufficient to create the intricate structure we see. The web required the head start provided by dark matter, which began to collapse and form structure even before the ordinary matter could do so, creating the gravitational wells into which ordinary matter later fell. This means that the cosmic web we see, the luminous, glowing network of galaxies and gas, is merely the visible surface of a much vaster, invisible structure. The true cosmic web is dark matter, and it extends, in principle, right through the voids that appear empty to our instruments. The voids are not truly empty, they contain dark matter filaments too thin and too tenuous to have gathered significant amounts of ordinary matter, but present nonetheless, subtle curvatures in space that betray the ghost of the primordial web even in the most seemingly desolate expanses of the universe. And then there is dark energy, something even more mysterious. It's a property of space itself, it seems, a kind of energy intrinsic to the vacuum, that drives the accelerating expansion of the universe. Dark energy is the reason the universe is expanding faster today than it was in the past, the reason that distant galaxies are receding from us at increasing speeds, the reason that, billions of years from now, most of the observable universe will have expanded beyond the cosmic horizon and become forever invisible to any observer in our galactic neighborhood. Dark energy acts, in a sense, as the opponent of the cosmic web. While gravity pulls matter together, building the web's filaments and nodes, dark energy stretches space, diluting the density of matter, working against the continued growth of structure. In the early universe, when matter was dense and dark energy was a smaller fraction of the total energy budget, gravity won, structure grew, the web became more intricate and more massive over time. But as the universe expanded and the density of matter decreased, dark energy, which does not dilute as the universe expands but remains roughly constant per unit volume of space, dark energy gained the upper hand, and the growth of the cosmic web slowed, and eventually will stop, and then reverse, as dark energy drives the universe's expansion to ever greater speeds, eventually stretching the cosmic web apart into an increasingly diffuse and isolated collection of gravitationally bound islands. We live, in cosmic terms, at approximately the peak of the cosmic web's complexity. The universe today has had just enough time for gravity to build the magnificent structure we observe, but dark energy has not yet had time to significantly disrupt it. We are, in the most literal sense, witnessing the cosmic web at its moment of greatest beauty, and the Webb Space Telescope is our instrument for appreciating that beauty in its full depth and history. Let that thought breathe. You are here. at the perfect moment in cosmic history, to witness the universe's greatest work of art at its most complete. There is another aspect of the cosmic web that Webb has illuminated with particular vividness in its extended observations, and it is one of the most human of all the things we find in the depths of space: the idea of connection, of relationship, of belonging to something larger than oneself. The galaxies of the cosmic web are not isolated objects. They are connected to one another by the filaments of gas and dark matter that flow between them. They influence one another across vast distances through gravity and through the radiation they emit. They exchange matter over billions of years, gas streaming along the filaments, being captured, expelled, recycled. And the galaxy clusters at the nodes of the web are not simply accumulations of galaxies that happen to be nearby. They are the products of the web structure. They have grown by accreting other galaxies along the filaments, growing more massive over time, their gravitational influence extending further and further into the surrounding filaments, drawing in more and more material. This process of growth by accretion along filaments is one of the key ways that the cosmic web evolves, and it has a name that captures something of its dynamic nature: cosmic accretion, the slow, steady feeding of the great structures at the web's nodes by the rivers of matter flowing along its threads. Webb has observed this process in exquisite detail, finding galaxies being stripped of their gas as they fall into clusters along filaments, finding streams of fresh, pristine gas flowing into actively star-forming galaxies along the web's threads, finding evidence for the continuous, dynamic exchange of matter that keeps the cosmic web alive and changing. Our own Milky Way, the galaxy in which our solar system resides, is itself a product of this process. It sits, along with a few dozen other galaxies, in a small overdensity of the cosmic web known as the local group, which is itself part of a larger structure called the Virgo Supercluster, which is part of an even larger structure called Laniakea, a vast supercluster of galaxies that spans approximately 500 million light-years and contains the mass of 100 million billion suns. And Laniakea is part of the cosmic web, one node among countless others, one intersection of filaments in the vast, spanning network that organizes the observable universe. When you look up at the night sky and see the faint smear of light that is our own galaxy's disk, you are looking at the local expression of the cosmic web. You are inside one of the web's filaments, in a node of modest mass, on the outskirts of a region that will, over the next several billion years, continue to accrete matter and grow. You are not an outside observer of the cosmic web, you are embedded within it, a conscious expression of one of its smallest but most intricate features. And as you breathe, as you let your awareness settle and soften, let that sense of embeddedness be a comfort. You are held within the web, cradled, in a way, by the same gravitational structure that has organized the universe since its earliest moments. The voids, let us speak for a moment of the voids, because they are as much a part of the cosmic web as the filaments and nodes, and in their own way, they are just as beautiful and just as profound. The voids are the great empty spaces between the filaments, regions of space that can span hundreds of millions of light-years in which there are almost no galaxies, almost no gas, almost nothing but the faintest wisps of the intergalactic medium and the invisible dark matter that flows, slowly and inexorably, toward the walls and filaments that border them. They are not truly empty, as we have noted, but they are so much less dense than the rest of the universe that to call them empty is forgivable and perhaps even appropriate. The voids are regions from which gravity has been draining matter for billions of years. As the filaments and clusters have grown, they have drawn matter away from the surrounding regions, leaving the voids increasingly depleted. And this process has accelerated over time as the universe's expansion has stretched the voids wider and wider, making it increasingly difficult for the sparse matter within them to find its way to the gravitational wells at their edges. There is a haunting quality to the voids, a sense of cosmic loneliness that is perhaps appropriate given their nature. To live in a galaxy embedded deep within a void, as a tiny fraction of galaxies do, would be to look out at a night sky almost entirely devoid of other galaxies, to inhabit a universe that appeared, from the local perspective, to be nearly empty. The nearest neighbors would be hundreds of millions of light-years away, so far that even the most powerful telescopes would struggle to detect them. And the cosmic microwave background, the ancient afterglow of the Big Bang, would be the only evidence that this lonely island of stars existed within a larger structure. And yet, even in the voids, the cosmic web's influence is felt. The galaxies that do exist in voids are subtly different from those in filaments and clusters. They tend to be bluer, actively forming stars, less disturbed by gravitational interactions with neighbors. They are, in a sense, the freest galaxies in the universe, untouched by the constant gravitational pushing and pulling that shapes the lives of galaxies in the dense regions of the Webb. And in their freedom, they reveal something about what galaxies might be like without the cosmic web's organizing influence, isolated experiments in stellar evolution, running without the complications of environment. Webb has observed void galaxies with particular interest in recent years, using them as natural laboratories for understanding how galaxies evolve in the absence of environmental influences. And what those observations reveal is that the cosmic web is not merely a structural feature of the universe, it is an active participant in the evolution of every galaxy within it, shaping their star formation rates, their morphologies, their chemical compositions, their very natures. The Webb is not a passive backdrop, it is a dynamic environment that leaves its mark on every galaxy it contains. You are drifting now, gently, through the vast, quiet spaces of the cosmic web, letting the stars and filaments and voids wash over your awareness like the surface of a slow, gentle sea. Let us come now to one of the most remarkable discoveries that the extended Webb observations of 2026 contributed to our understanding of the cosmic web, the discovery of what researchers have come to call protoweb structures at the highest accessible redshifts, at distances so great and times so early that the universe was only a few 100 million years old, barely an infant in cosmic terms. At these extreme distances, Webb sensitivity in the infrared allowed it to detect faint overdensities of galaxies, regions where the primordial quantum fluctuations had been large enough to drive early and rapid galaxy formation. And in some of these overdensities, the galaxies were not scattered randomly but showed a distinct tendency to align along certain preferred directions, to arrange themselves in linear or planar structures that suggested the very first emergence of the filamentary pattern that would, over billions of years, become the mature cosmic web. These protofilaments, these embryonic threads of the Great Web, are among the most ancient large-scale structures ever observed. They are the web in its infancy, fragile and tenuous compared to the massive filaments of the modern universe, but unmistakably present, unmistakably organized, already expressing the fundamental pattern that gravity would continue to build upon for the next 13 billion years. To see a protofilament in the deep web data is to witness a kind of cosmic birth, the moment when the universe's largest structures first began to take shape, when the diffuse, nearly uniform gas of the early universe first began to feel the organizing pull of the primordial dark matter web that had already, even then, been quietly assembling itself since the universe's first moments. There is a deep irony in the fact that dark matter, which we cannot directly see, was the first architect of the cosmic web. It began to collapse and form halos and filaments even before ordinary matter could do so, because ordinary matter was still coupled to the radiation field, held in a state of constant agitation by the intense pressure of photons, unable to collapse under gravity until the universe had cooled enough for atoms to form and for matter and radiation to decouple. The moment of decoupling, approximately 380,000 years after the Big Bang, is the moment recorded in the cosmic microwave background, that all-pervasive glow of ancient light that fills the universe uniformly to within 1 part in 100,000, those tiny variations, those infinitesimal ripples in the temperature of the microwave background, are the direct imprint of the quantum fluctuations from which the cosmic web grew. They are the web's DNA, the blueprint written in light from the universe's earliest moments. And Webb, though it cannot directly observe the microwave background, can see the structures that grew from those fluctuations, can trace the web's history from its earliest manifestations in the protofilament of the first billion years, through the growing complexity of the middle cosmic ages, to the mature, intricate network of the present universe. And in doing so, it can test, with unprecedented precision, whether our theoretical understanding of how the web formed is correct, whether the lambda CDM model, the standard model of cosmology that describes a universe dominated by dark energy and cold dark matter, correctly predicts the web's properties at all epochs. And here is where things become genuinely interesting, genuinely mysterious, because the Webb observations of the cosmic web have revealed a number of features that are in tension with the simplest versions of our theoretical predictions, features that suggest our understanding, while broadly correct, is incomplete in ways that physicists are only beginning to understand. The most striking of these tensions is the existence, in the early universe, of galaxy clusters that are more massive and more numerous than the standard model predicts should exist at such early cosmic times. These massive early clusters, some of which appear to already have masses comparable to the largest clusters in the modern universe when the universe was less than 2 billion years old, are challenging theorists to refine their models, to consider whether dark matter behaves differently than the simplest cold dark matter model assumes, to explore whether there are additional physical processes at work in the early universe that accelerate the growth of structure beyond what gravity alone should produce. This is not a crisis for cosmology, it is a gift. The most productive thing an observation can do is not to confirm what we already knew, but to reveal a subtle discrepancy, a gentle anomaly, a whisper from the universe that says, "You are on the right track, but you have not yet arrived." There is more to understand. There is more to discover. The universe is, as it has always been, more complex and more beautiful than our current best theories capture. And so, as you rest in this calm and quiet space, as the universe spreads around you in its vast and luminous web, know that you are living in a time of active discovery, a time when humanity's understanding of its place in the cosmos is being refined and deepened by instruments of extraordinary sensitivity and by the patient, careful work of thousands of scientists around the world, working together, across languages and cultures and time zones, to understand the structure of everything. The cosmic web is not just an abstract scientific concept, it is the most tangible expression of the universe's deepest organizing principles. It is gravity, working patiently over cosmic time, organizing matter into the most intricate structure that physics allows. It is quantum mechanics, translating the uncertainty of the earliest moments into the density variations from which all large-scale structure grew. It is thermodynamics, driving the flow of matter from high-density regions to even higher-density regions, from voids to filaments to clusters. It is electromagnetism, allowing the ordinary matter within the web to cool and condense and form galaxies and stars and planets and life. All of physics is at work in the cosmic web, all of the universe's fundamental forces and principles are expressed, at the largest scales, in the structure of this magnificent network. And in the light that Webb gathers from the depths of the universe, the light that crosses billions of light-years to fall on those golden mirrors in the cold silence beyond the orbit of the moon, in that light is encoded the story of how the cosmic web came to be, how it grew and evolved, how it shaped the galaxies within it, and how those galaxies, in their turn, shaped the chemistry of the universe and ultimately made possible the existence of planets and life and consciousness and the ability to look back, across the whole sweep of cosmic history, and wonder at the structure of everything. Let that wonder be present with you now, soft and warm and without urgency, just a gentle recognition of the magnificent place you inhabit, the magnificent story you are part of. As Webb's observations have deepened our understanding of the cosmic web structure, they have also revealed something beautiful about the relationship between the web and the galaxies that inhabit it, a relationship that is not one of passive residence but of active, dynamic co-evolution. The web shapes the galaxies, yes, but the galaxies also shape the web, and this mutual influence is one of the most fascinating areas of current research in cosmology. Galaxies are not quiet inhabitants of their cosmic environment. They are energetic, often violent, continuously transforming their surroundings. The most massive galaxies harbor supermassive black holes at their centers, black holes with masses ranging from millions to billions of times the mass of our Sun. And these black holes, when they are actively accreting matter from their surroundings, become extraordinarily luminous objects called quasars or active galactic nuclei, pouring out radiation and particle jets that can extend for millions of light-years in either direction, heating the surrounding intergalactic medium, preventing gas from cooling and falling into the galaxy, effectively regulating their own growth and the growth of other galaxies nearby. This process, called AGN feedback, is one of the key regulatory mechanisms that prevents the most massive galaxies from forming stars indefinitely, that quenches their star formation and turns them from blue, actively star-forming galaxies into the red, quiescent elliptical galaxies that dominate the cores of the great clusters at the nodes of the cosmic web. And the energy deposited by AGN feedback into the surrounding intergalactic medium affects the density and temperature of the gas in the filaments, subtly modifying the environment of the web itself. Similarly, the most rapidly star-forming galaxies drive powerful winds of gas and dust into the intergalactic medium, supernova-driven outflows that can extend for tens of thousands of light-years beyond the galaxy's disk. These winds carry with them the heavy elements produced by stellar nucleosynthesis, enriching the intergalactic medium with the metals that will eventually be incorporated into the next generation of galaxies along the filaments, ensuring a continuous chemical enrichment of the cosmic web that has been proceeding, gradually, since the first massive stars lived and died in the early universe. The cosmic web is, in this sense, a recycling system of extraordinary efficiency and beauty. Matter falls along the filaments into galaxies, galaxies process it into stars and planets and, in the most interesting cases, into life, and then, through stellar winds and supernova explosions and AGN-driven outflows, they return a fraction of that matter, now chemically enriched, to the surrounding intergalactic medium, where it eventually cools and condenses and falls into the next generation of galaxies, a cosmic cycle of matter and energy that has been running for more than 13 billion years and will continue for many billions of years to come. You are part of that cycle. The atoms of your body have been through this process many times, forged in stars, scattered through the interstellar medium, gathered into new molecular clouds, incorporated into new stars and planetary systems, cycling through the cosmic web on timescales that dwarf the entire history of life on Earth. And yet, for all the vastness of those timescales, for all the incomprehensible scales of space and time through which your atoms have traveled, here you are, present in this moment, breathing slowly, feeling the gentle weight of your body settling into rest, and perhaps beginning to sense, in some quiet and wordless way, that the distance between you and the farthest filament of the cosmic web is not quite as absolute as it might first appear. Because the cosmic web is not something separate from you, it is not a distant structure that exists out there, beyond the reach of ordinary experience, it is the architecture within which your existence is embedded, the large-scale scaffolding of reality itself, and every atom that composes your body, every molecule that carries your thoughts, every electrical impulse that moves through your nervous system in this very moment. All of it is part of the same continuous fabric that stretches across the observable universe, the same fabric that the James Webb Space Telescope has been revealing to us in unprecedented detail, the same fabric that cosmologists spend their lifetimes trying to understand. And as you drift deeper into relaxation now, as your breath becomes slower and more natural, as the thoughts of the day grow quieter and more distant, I want to invite you to simply rest in that understanding for a while, to let the enormity of what we have been exploring together settle gently into your awareness, not as something demanding or overwhelming, but as something profoundly peaceful, profoundly reassuring. Because there is something deeply calming about understanding your place in the cosmic web, something that dissolves the small anxieties and preoccupations of daily life, when you contemplate the fact that the universe has been weaving this magnificent structure for more than 13 billion years, that the filaments we can now observe with Webb span hundreds of millions of light-years, that the voids between those filaments contain less matter than almost any space that has ever existed in the history of the cosmos. Something in that contemplation invites the mind to release its grip, to soften its edges, to rest in something larger than itself. The James Webb Space Telescope, floating in its quiet orbit around the second Lagrange point, 1.5 million kilometers from Earth, has given us eyes that can see further into the past than any instrument in human history, and what those eyes have revealed, through years of careful observation and painstaking analysis, is a cosmic web that is more intricate, more dynamic, and more beautiful than even our most sophisticated computer models had predicted. The protoclusters that Webb has identified in the early universe, those dense regions where dozens or even hundreds of galaxies are gathering around the great nodes of the web, show us the cosmic structure in the process of being assembled, galaxies that are still finding their places in the hierarchy, still accreting the gas and dark matter that will eventually make them into the massive elliptical galaxies we see at the centers of galaxy clusters today, still in the midst of that extraordinary burst of star formation that characterized the cosmic noon, when the universe was building more stars per unit time than at any period before or since. And the filaments connecting those protoclusters, those great rivers of matter flowing through the intergalactic medium, carry within them the thermal and chemical history of billions of years of cosmic evolution. The warm, hot intergalactic medium that fills those filaments holds the majority of the ordinary baryonic matter in the universe, matter that once resided in galaxies, matter that was processed through stellar interiors, enriched with heavy elements, and then expelled into the surrounding space by the very processes that make galaxies bright and visible and scientifically interesting. There is a kind of generosity in that, a cosmic generosity, galaxies taking in the raw material of the universe, transforming it through the alchemy of stellar nucleosynthesis, and then returning it, enriched and altered, to the larger web, so that other galaxies, forming later and in different places, can begin with a richer initial supply of the elements that make complex chemistry possible, that make rocky planets possible, that make biology possible. And Webb has begun to trace this generosity in extraordinary detail, measuring the metallicity of the intergalactic medium in filaments at different cosmic epochs, watching the gradual enrichment of that medium as successive generations of stars live and die and scatter their products into the surrounding space, building up, over billions of years, the chemical complexity that is the prerequisite for everything that follows. You are the endpoint of that enrichment, the temporary repository of elements that were forged across multiple stellar generations. The carbon in your cells was synthesized in the triple alpha process in the cores of red giant stars. The oxygen in your lungs was produced in the later stages of massive stellar evolution and then scattered by supernova explosions. The iron in your blood was created in the final moments of stellar collapse, in the extraordinary violence of core collapse. Supernovae, and all of these elements, after their creation and dispersal, spent time in the intergalactic medium, cycling through the cosmic web, before eventually finding their way into the molecular cloud that collapsed to form the Sun and its planetary system, and then into the chemistry of the early Earth, and then, through the long and astonishing story of biological evolution, into you. So when the Webb telescope images a filament of the cosmic web at redshift 3, when it captures the faint glow of intergalactic gas stretched across millions of light-years, it is in some sense looking at the raw material of future beings, future chemistries, future forms of complexity that none of us can imagine, because the cosmic web does not stop, it does not reach a final state and become static and unchanging. It continues to evolve, slowly and majestically, driven by the same gravitational and thermodynamic processes that have been shaping it since the very first moments after the Big Bang. In the far future, billions of years from now, the accelerating expansion of the universe driven by dark energy will gradually stretch the filaments of the cosmic web to even greater lengths, will isolate the great galaxy clusters from one another as the space between them expands faster than gravity can pull them together, will eventually create a universe in which the cosmic web's largest structures are frozen in place, no longer able to accrete new matter from their surroundings, a universe that is, in a sense, winding down toward its final configuration. But that is a very long time from now, and in the meantime, the web continues to pulse with the slow heartbeat of cosmic structure formation, continues to channel matter toward the nodes where galaxies cluster and star formation proceeds, continues to exchange gas and energy between the small-scale structures of individual galaxies and the vast large-scale architecture within which those galaxies are embedded. And the James Webb Space Telescope continues to watch, continues to gather the ancient light of distant galaxies and protoclusters and filaments, continues to build our picture of this structure across cosmic time, helping us understand not just what the universe looks like at any given moment, but how it got to be the way it is, how the smooth, nearly uniform sea of matter that existed after recombination could have evolved, under the influence of gravity and dark matter and the initial conditions imprinted by inflation, into the magnificent web of filaments and nodes and voids that we observe today. And one of the most profound insights that emerges from all of this, from the decades of theoretical work and observational campaigns and computer simulations and now the stunning new data from Webb, is that the cosmic web was, in a very real sense, inevitable, given the physics of the early universe, given the spectrum of density fluctuations imprinted by inflation, given the properties of dark matter and dark energy. The emergence of large-scale structure was not a matter of chance, but of necessity. The universe was always going to develop this characteristic pattern of filaments and voids and nodes. It was written into the initial conditions from the very beginning. And that, perhaps, is the most astonishing thing of all, that a universe born in the extraordinary violence of the Big Bang, expanding outward in all directions from a state of almost unimaginable density and temperature, carried within its initial conditions the seeds of every galaxy, every star, every planet, every living creature that would ever exist, that the cosmic web we see today was in some sense already present, encoded in the quantum fluctuations of the inflationary epoch, waiting for 13 billion years of gravitational amplification and cosmic evolution to bring it into the visible, luminous, magnificent form that Webb can now image in such extraordinary detail. Rest now, and let that thought settle gently through you, like light passing through still water. The universe knew, from its very first moments, that it would become this, knew that it would weave this great web of matter and energy across the entirety of its observable extent, knew that within the nodes of that web, stars would form and shine and die, knew that in the orbits of those stars, rocky worlds would coalesce from the dusty remnants of supernovae, and knew that on at least one of those worlds, matter would organize itself into the extraordinary complexity of living systems, and that those living systems would eventually look back, with instruments of their own creation, and begin to understand the web within which they have always been embedded. There is a kind of completion in that, a kind of cosmic self-awareness, the universe coming to know itself through the minds and instruments of the beings it has created, and the James Webb Space Telescope is perhaps the finest expression of that self-awareness that human civilization has yet produced, a mirror held up to the cosmos at the very limit of our technological capability, reflecting back to us images of the web that gave us birth. As your body grows heavier and more comfortable, As your breathing settles into the deep, regular rhythm of approaching sleep, let the images from Webb drift through your mind like slowly moving clouds, the great filaments of the cosmic web glowing faintly in the infrared, the protoclusters studded with young blue galaxies still assembling their first generations of stars, the vast dark voids where matter is almost entirely absent, the nodes where hundreds of galaxies cluster together in the gravitational embrace of enormous dark matter halos. All of it moving, slowly, over timescales so vast that a human lifetime is less than an eye blink, all of it connected, in ways that are only now becoming fully apparent, by the invisible threads of the warm hot intergalactic medium and the dark matter filaments that thread through the visible structure like a skeleton beneath the skin. The cosmic web is patient, it does not rush, it has all the time in the universe, quite literally, to do what it does, and in its patient, unhurried, majestic unfolding, there is a lesson, perhaps, for those of us who sometimes struggle to slow down, who sometimes forget that the most important things are not the things that happen quickly, but the things that happen over the deepest timescales, the things that build slowly and quietly and inevitably toward configurations of extraordinary beauty and complexity. The universe built its web over 13 billion years, and it will continue building it for many billions of years to come, and in the grand architecture of that web, the brief, bright flash of a human lifetime is not insignificant, it is not irrelevant, it is, rather, a perfect expression of what the cosmic web is ultimately for, a place where matter organizes itself into sufficient complexity to contemplate its own origins, where the universe, through the medium of conscious beings, achieves something that no amount of dark matter or gravitational collapse alone could ever produce, the capacity for wonder. And wonder is what you have been feeling, perhaps, throughout this journey through the cosmic web, that soft, wordless opening of the mind that happens when you encounter something genuinely too large to fully comprehend, when the scale of what you are contemplating exceeds the ordinary categories of thought and invites a different kind of knowing, a knowing that is less about analysis and more about presence, less about understanding and more about being. This is the gift of cosmology at its deepest level, not just the facts and figures and redshifts and metallicities, not just the dark matter halos and the Lyman alpha forest and the warm hot intergalactic medium, but the felt sense of existing within something vast and ancient and continuously unfolding, the sense of being, at every moment, embedded in a structure that dwarfs comprehension, and finding that, rather than being frightening or alienating, this is actually deeply, profoundly comforting. Because the cosmic web does not exclude you, it includes you, it is not indifferent to you in the way that cold empty space might seem to be, it is, in a very real sense, the reason you exist, the reason the atoms that compose you were forged and scattered and gathered and assembled into the particular configuration that you are. The web provided the architecture within which everything you have ever known or loved or thought or felt became possible. And so as you close your eyes now, as the last images from the James Webb Space Telescope fade gently from your conscious mind, let that sense of inclusion remain, let it settle into the background of your awareness like a quiet light, the sense of being held within something vast and patient and ancient, something that has been weaving its great structure for longer than the Earth has existed, and will continue weaving it long after every star you can see in the night sky has burned out and faded into darkness. You are a temporary gathering of the cosmos upon itself, a brief but real concentration of the matter and energy that flows through the web, and in this moment, as sleep begins to claim you gently, you are returning, in the smallest and most personal way, to that state of quietness and simplicity that preceded all structure, the state of rest from which complexity always eventually emerges. The filaments of the cosmic web stretch across hundreds of millions of light-years in every direction, the great voids open their dark and silent spaces between them, the nodes pulse with the slow life of star-forming galaxies and ancient ellipticals and the supermassive black holes at their centers, and at the heart of all of it, threading through every scale of structure from the smallest quantum fluctuation to the largest coherent pattern in the observable universe, is the same. Underlying physics, the same gravitational love that draws matter toward matter, the same thermodynamic arrow that points from simplicity toward complexity and then, eventually, back toward rest. Follow that arrow now, let it carry you from the complexity of your waking mind toward the simpler, quieter state of sleep. Let the cosmic web recede into the distance, a faint and beautiful glow at the edge of perception, a reminder, even in sleep, of the magnificent structure within which your dreaming mind continues to exist. The James Webb Space Telescope will continue its observations through the night, gathering the light of galaxies that emitted that light before the Earth existed, building our understanding of the web that spans the universe, and in the morning, perhaps, there will be new images, new data, new discoveries that push our knowledge a little further out along the great filaments of space and time. But for now, for this night, the only thing that matters is the slow descent into rest, the gradual quieting of thought and sensation, the body growing heavier and more relaxed with every breath, the mind releasing its grip on the day and drifting, gently and inevitably, toward sleep. The cosmic web is there, always present, always weaving its great pattern through the darkness between the galaxies, and it will be there when you wake, and there when you sleep again, and there in every moment of your brief and luminous life within it. Rest now, drift now, let the universe hold you gently in its ancient arms, and sleep. The filaments glow faintly in the dark, the galaxies drift slowly in their gravitational dances, the voids breathe in their immense and silent patience, and you, here, now, breathing slowly and deeply, are exactly where you need to be. Sleep can dream of the web. Close your eyes now, if you haven't already, and let the darkness behind your eyelids become something vast and beautiful. Let it become the darkness between the galaxies, that ancient, patient darkness that has been waiting since the very beginning of time for you to notice it, to rest within it, to let it hold you as gently as it holds every particle of matter that has ever existed. The James Webb Space Telescope continues its quiet vigil out there, beyond the protective warmth of Earth's atmosphere, suspended at a gravitational equilibrium point called Lagrange 2, 1.5 million kilometers from our small blue world, and in the year 2026, it has been watching the cosmos with its golden mirrors for years now, accumulating light that has traveled billions upon billions of years to reach it. Light that carries within it the memory of the universe's earliest architecture, the first faint outlines of the cosmic web. And that web, that extraordinary, incomprehensible structure, is what we have been slowly, gently, meditatively exploring together tonight, and now, in these final quiet moments before sleep takes you fully, we will let our understanding of it settle into something deeper than knowledge, something more like feeling, more like wonder, more like the peaceful recognition that you are part of something so beautiful and so vast that the human mind can only approach it in moments of stillness. Breathe in slowly, and imagine your breath carrying you outward, past the familiar ceiling of your room, through the quiet atmosphere above, through the thin and starry layers where satellites trace their careful paths, and out into the space beyond, where the stars hang suspended in their patient light. The cosmic web, as JWST has revealed it to us in its extraordinary detail, is not simply a structure of matter, it is a structure of time, because when we look outward across the universe, we are always, inevitably, looking backward through time. Every photon that reaches the telescope's golden mirror has been traveling since some moment in the past, and the farther it has traveled, the older it is, and the older it is, the more it shows us of the universe's earliest youth. And youth, even cosmic youth, has its own particular quality of light. The universe in its earliest epochs was not dark and empty as it is now. It was hot and bright and filled with plasma, a roiling, energetic soup of particles and radiation that was, in its own strange way, far more intimate than the vast cold distances of the present universe. Everything was connected to everything else in that primordial brightness. There was no separation, no void, no empty space, only the luminous, churning unity of a cosmos that had not yet learned to spread itself thin across unimaginable distances. And then, slowly, over hundreds of millions of years, that unity began to differentiate, began to find its shape, and the shape it found was the cosmic web. The slight variations in density that existed from the very first moments after the Big Bang, quantum fluctuations that were stretched to cosmic scales during an early period of explosive expansion, these tiny ripples in the fabric of matter became, over time, the seeds of everything we see, the seeds of filaments and walls and sheets and nodes, the seeds of the great web that now spans the observable universe like the most intricate and delicate architecture ever created. And JWST, in the year 2026, has been able to look back far enough, with sufficient sensitivity, with sufficient clarity, to see those seeds beginning to sprout. There is something profoundly moving about that, about the idea of seeing the very beginnings of structure in the universe, of watching, across billions of years of cosmic time, the moment when the web first began to take shape, when the first filaments began to draw matter together along their luminous threads, when the first nodes began to gather mass and warmth and light. It is like watching the universe dream its first coherent dream. And we, here, now, watching from our small planet orbiting our middle-aged star in one spiral arm of one ordinary galaxy among hundreds of billions, we are the part of the universe that has become capable of looking back and recognizing the dream, and finding it beautiful. Let that thought rest with you for a moment, let it settle into the quiet spaces between your thoughts, the idea that the universe has, through the extraordinary accident of evolution and consciousness, found a way to contemplate its own structure, and that you, in this moment of stillness and approaching sleep, are part of that contemplation. You are not separate from the cosmic web, you are an expression of it, a local, temporary, extraordinarily complex concentration of the same matter and energy that forms the filaments and nodes and sheets of the largest structure in existence. The carbon in your body was forged in stellar interiors, the iron in your blood was scattered by supernovae, the calcium in your bones, the oxygen in your lungs, the hydrogen in every molecule of water in every cell, all of it emerged from the same cosmic processes that built the web. You are, in the most literal and profound sense, a node in the cosmic web, the place where complexity has concentrated, where matter has organized itself into something capable of awareness and wonder. And now that awareness is releasing itself, letting go of its careful organization for a little while, drifting into the beautiful dissolution of sleep. The James Webb Space Telescope, as it has continued its observations into 2026, has not only shown us the grand architecture of the cosmic web, it has also shown us what lies within that architecture, the galaxies that cluster along the filaments like dewdrops on a spider's thread, each one a vast collection of stars, each star potentially orbited by worlds, each world potentially the home of something that looks up at its own sky and wonders. When JWST images a distant filament of the cosmic web, what appears in those images is not the filament itself, precisely because the filament is made mostly of dark matter, which does not emit or absorb light in any form we can directly detect. What appears in the images are the galaxies that trace the filament's path, arranged in long, graceful arcs and chains across the field of view, their light reddened and dimmed by the vast distances and the expansion of space, but unmistakably organized, unmistakably following the invisible architecture of the web. It is like watching fireflies trace the outline of a forest at night. You cannot see the trees themselves in the darkness, but the pattern of the lights tells you exactly where they are. The galaxies are the fireflies, and the dark matter filaments are the trees, and the forest is so enormous that its edges are beyond any horizon we can yet see. Breathe in and out, and let your mind drift along one of those filaments. Let it follow the curve of matter through space. pass galaxy after galaxy, each one 100 billion stars, each one separated from the next by distances so large that light takes millions of years to cross them, and yet all of them connected, all of them part of the same continuous thread of matter winding through the darkness. The filaments of the cosmic web are the highways of the universe, and the galaxies that travel along them are not static, they are moving, always moving, following the gravitational gradient of the filament toward its destination, which is always a node, a great cluster of galaxies where thousands of island universes gather together in a gravitational embrace that will last for billions of years. These galaxy clusters, the great nodes of the web, are among the most spectacular and most extreme environments in the universe. They are filled with hot gas, heated to temperatures of tens of millions of degrees by the violence of countless collisions and mergers over cosmic time, and that hot gas glows in X-rays, invisible to our eyes but brilliantly apparent to telescopes designed to see those energetic photons, great halos of fiery gas surrounding the compact concentrations of galaxies at the cluster's hearts. JWST does not see X-rays, but it works in beautiful concert with X-ray observatories like Chandra, and together, these different eyes on the universe build a picture that is far more complete than any single telescope could achieve. The X-rays show us the hot gas, the infrared light that is JWST's specialty shows us the galaxies and their stars, and the gravitational lensing that the entire cluster produces shows us, indirectly, the distribution of dark matter that provides the scaffolding for everything else. It is a collaborative act of seeing, a kind of cosmic forensics in which multiple lines of evidence converge toward the same conclusion. This is how structure formed, this is how the web was built, this is how the universe organized itself from smooth, hot plasma into the extraordinary intricate architecture we observe today. And as you listen to these words, as the concepts settle gently through the layers of your consciousness, you need not hold them with any particular effort. They are not facts to be memorized or understood with precision. They are textures of wonder, invitations to feel the scale and beauty of what exists, and then to rest within that feeling as deeply and peacefully as you rest within your bed tonight. The warmth of your blanket, the softness of your pillow, the quiet sounds of wherever you are, these are not separate from the cosmic story we have been telling together. They are part of it. The web includes this room, includes this moment, includes the particular arrangement of atoms that is you, breathing slowly in the dark. Let your body grow heavier, let the surface beneath you become more real, more present, more comforting, and let your mind grow lighter, let it float upward and outward toward the stars while your body rests in perfect stillness. JWST has given us, among its many extraordinary gifts, something called deep field imaging, images of tiny patches of sky that have been observed for long periods of time, allowing the telescope to collect enough light to reveal the faintest and most distant objects so far away that their light has been traveling since the universe was only a few 100 million years old. In these deep field images, every point of light, every smear of color, every faint blur is a galaxy, not a star, but a whole galaxy, 100 billion stars gathered together, and in the image, they are so numerous and so varied in their shapes and colors that the mind struggles to process what it is seeing. It is, in the most literal sense, too much beauty to take in all at once. Some of the galaxies in these images are round and smooth, like softly glowing eggs. These are the elliptical galaxies, the ancient ones, their star formation long since completed, their populations aging gracefully like embers cooling after the main fire has burned down, and others are disc-shaped, with spiral arms trailing behind them like the arms of a dancer caught in a slow spin, and others are irregular, their shapes distorted by collisions and interactions with neighbors, their forms caught in the middle of transformation. And all of them, in the deep field images, are arranged not randomly but in a pattern. You can see the pattern if you look. There are places where galaxies cluster together in groups and chains, and there are places where the image is strikingly empty, voids in miniature, within the field of view, and these patterns are the cosmic web projected on the two-dimensional canvas of the sky, the three-dimensional architecture compressed into a single extraordinary image. It is one of the most humbling experiences available to a human being to look at one of these deep-field images and to understand, truly understand, that every single point of light represents a galaxy, and that this tiny patch of sky, this fragment no larger than a grain of sand held at arm's length, contains thousands of such galaxies, and that the sky contains millions of such patches, and that in each one, there are thousands of galaxies, and the mathematics of it leads to a number so large it has no meaning in ordinary human experience. Hundreds of billions of galaxies in the observable universe. And beyond the observable universe, beyond the horizon defined by the finite age of the cosmos and the finite speed of light, there is almost certainly more, perhaps infinitely more. The universe almost certainly extends far beyond what we can ever see, no matter how sensitive our instruments become. And all of it, all of this almost incomprehensible vastness, is organized into the cosmic web. Let that thought be a comfort rather than an overwhelm. Let it be the kind of thing that makes you feel small in the best possible way, the way you feel small when you stand beside the ocean, or beneath a mountain, or under a truly dark sky full of stars, small in a way that is releasing rather than frightening, because when you recognize how vast the universe is, the particular weight of your day, your worries, your concerns, they become lighter, they find their proper proportion against the background of something infinite and ancient and beautiful. And you can rest in that proportion now, you can let the smallness be restful. Breathe in and out. The filaments glow, even now, as you listen, the great threads of the cosmic web stretch across the darkness, connecting cluster to cluster, void to void, carrying within them the slow current of matter moving always toward greater concentrations of gravity, always toward the nodes where the galaxies gather in their brilliant crowds. There is a filament, or rather, there are many filaments, that connect directly to the supercluster of which our own Milky Way is a part. We live within a structure called the Laniakea Supercluster, a name derived from the Hawaiian words for immeasurable heaven, and Laniakea is itself a node, or the beginning of a node, a concentration of matter and galaxies within the larger web that spans a volume of space roughly 500 million light-years across. Within Laniakea, our galaxy moves, slowly, inexorably, toward a concentration of mass called the Great Attractor, a region of space where the gravitational pull is strong enough to draw thousands of galaxies in its direction, including our own. We are, right now, even as you lie here in peaceful stillness, moving toward the Great Attractor at hundreds of kilometers per second. But the universe is also expanding, space itself is stretching, and the expansion of space, on large scales, overwhelms the gravitational attraction that pulls matter together, so the web is not collapsing inward on itself, it is simultaneously growing and organizing. The nodes grow denser as matter flows along the filaments to join them, but the voids grow larger as space expands and the matter within them continues to thin out. The universe is, in a sense, sorting itself, separating the dense from the sparse, concentrating matter in some places while leaving other places almost completely empty, and this sorting process has been underway for the entire history of the cosmos, and it will continue for far longer than it has already lasted. In the far future, billions and billions of years from now, the voids will be so vast and so empty that even the faint intergalactic medium that currently fills them will have thinned beyond detection, and the galaxy clusters, the great nodes of the web, will have merged into enormous, slowly cooling elliptical galaxies, islands of stars separated from each other by distances so great that no light from one could ever reach another in the remaining lifetime of the universe. But that future is unimaginably distant, and tonight is not a night for imagining distant futures. Tonight is a night for resting in the present, for feeling the warmth of the bed, the weight of the blanket, the quiet rhythm of breath moving in and out. your heart beats its patient rhythm, 60, 70, 80 times each minute, each beat a small pulse of life in the great stillness, and somewhere far above, the stars are doing their own slow pulsing, variable stars expanding and contracting over days and weeks and months, pulsars spinning at extraordinary speeds and sending beams of radiation sweeping across the galaxy like cosmic lighthouses. The universe is full of rhythms, full of pulses, full of the patient repetition of things that have been happening for billions of years. And your breath is one of those rhythms, your heartbeat is one of those rhythms, and in this moment of approaching sleep, those rhythms are becoming more regular, more relaxed, more deeply peaceful. The James Webb Space Telescope has also given us something that previous telescopes struggled to provide, a clear view of the intergalactic medium, the extremely diffuse gas that fills the space between galaxies, and particularly the filament of the cosmic web, where this gas is slightly denser than in the voids. This intergalactic medium is not nothing, it is a thin soup of hydrogen and helium, the original matter of the universe, still present in the spaces between the galaxies after all these billions of years. It has been processed somewhat, ionized by the radiation of countless quasars and hot stars, contaminated with heavier elements blown out of galaxies by stellar winds and supernovae, but it is still, in its essence, the primordial material, the stuff from which everything else was eventually made. And JWST can detect this intergalactic medium through a technique called absorption spectroscopy. When the light from a distant quasar passes through the intergalactic medium on its way to the telescope, the gas absorbs certain wavelengths of that light, leaving dark lines in the spectrum that tell us what the gas is made of, how dense it is, how fast it is moving, and how it is arranged in space. By studying many quasars in many directions, astronomers can build a three-dimensional map of the intergalactic medium, and when they do, they see the cosmic web written in absorption lines. The filaments show up as concentrations of absorbing gas, the voids show up as regions where the absorption is weaker, and the whole structure emerges from the data like a pattern emerging from noise. It is painstaking, patient work, the kind of work that takes years of observation and analysis before it yields its secrets, and that patience is itself a kind of meditation, a commitment to looking carefully at the universe for as long as it takes to understand what it is showing you. There is something to be learned from that kind of patience, the willingness to look without rushing, to accumulate evidence slowly, to trust that the pattern will eventually emerge if you give it enough time and attention. And perhaps that is one of the gifts of this moment, this quiet time before sleep, the gift of not rushing, of simply being present with what is, without needing it to be different, without needing to act or respond or achieve anything at all. Just breathing, just resting, just being here in the darkness while the universe continues its ancient and patient processes all around you. Let your jaw relax, let your shoulders drop, let your hands rest without grasping anything, and let your mind drift, slowly and without resistance, further into the soft and welcoming space of approaching sleep. One of the most extraordinary findings from JWST's observations of the cosmic web has been the discovery of what astronomers call protoclusters, the embryonic forms of galaxy clusters, seen as they existed billions of years ago, before they had finished assembling themselves from the raw material of the cosmic web. These protoclusters are collections of galaxies that are beginning to fall together under their mutual gravitational attraction. They are not yet the dense, hot, X-ray glowing clusters of the present universe. They are looser, more extended, more diffuse collections of galaxies that are in the process of organizing themselves into something more concentrated. And JWST can see them at epochs so early in cosmic history that the universe was only a fraction of its current age, protoclusters that existed when the universe was 1, 2, 3 billion years old, still young by cosmic standards, still in the process of building its web from the raw material of the Big Bang. In the light from these ancient protoclusters, there is sometimes something remarkable, the glow of hydrogen gas that suffuses the entire region, great clouds of gas that have been lit up by the intense radiation of star formation and active galactic nuclei within the cluster. These clouds can be hundreds of thousands of light-years across, filling the space between and around the galaxies of the protocluster with a diffuse, soft luminescence. JWST has seen these clouds in extraordinary detail, the filaments of gas connecting the galaxies to each other, the streams of material flowing along those filaments toward the densest concentrations of mass, the pockets of gas that are beginning to collapse into new stars and new galaxies. It is a picture of the cosmic web in the act of being built, not the finished architecture of the present universe, but the construction site, the scaffolding still visible, the workers still busy, the material still being shaped and placed and connected. And watching a construction site, even a cosmic one, has its own particular quality of wonder, because in a construction site, you can see the intention, you can see the pattern that is emerging from the effort, and the pattern that the universe is building with its construction site of gas and dark matter and gravity and time is nothing less than the most complex and beautiful structure that exists. The cosmic web. And you are resting within it now, a small and precious part of one of its nodes, and the web will hold you all through the night and into the morning, and into every morning that follows, because the web is not going anywhere, and neither are you, in any ultimate sense. The matter that makes you up has been part of the web since the universe was very young, and it will remain part of the web long after the particular pattern of it that is you has dissolved back into the great flowing current of cosmic matter? But not tonight. Tonight, that pattern persists, beautifully, temporarily, miraculously, and it rests. Let your eyes be still now, let the movements behind them slow and deepen. The dreams, if they come, will be gentle, they will carry with them some faint echo of the cosmic scale we have been dwelling in tonight, perhaps a sense of vast spaces, perhaps a feeling of connection to something enormous and patient and kind. The voids of the cosmic web are not truly empty, we have touched on this before, and it is worth returning to, as you drift deeper into sleep, because it is one of the most comforting truths in all of cosmology. Within the voids, those great bubbles of sparse space that make up most of the volume of the universe, there are still things, galaxies that formed in regions of slightly higher density within the void, faint, diffuse galaxies that are among the most isolated objects in the universe, separated from their nearest neighbors by distances far larger than the typical intergalactic gaps, and there is still the intergalactic medium, thin as a whisper but present, and there is still dark matter, the most diffuse concentrations of it imaginable, but still there. And there is something else in the voids, something discovered relatively recently and confirmed beautifully by JWST's observations, a faint network of subfilaments, structures within the void that are themselves organized, that show faint echoes of the web's architecture even in the regions of lowest density. The void is not the absence of structure, it is structure at its most attenuated, the cosmic web at its most whispered, the universe's pattern expressed so faintly that it took our most sensitive instruments to detect it. And this, perhaps, is the final and most beautiful lesson of the cosmic web, that pattern is everywhere, that structure persists even in the emptiest places, that the universe's impulse toward organization never fully surrenders to emptiness, even in the spaces between the spaces. There is no place in the observable universe that is truly without form, there is no darkness so complete that structure has entirely withdrawn from it, even the most isolated void contains within itself the faint echo of the web's architecture. And this means, in the most fundamental sense, that you are never truly isolated either, that even in your moments of greatest solitude, you are still connected, part of a pattern that extends to the furthest reaches of what exists, woven into the web as surely as any galaxy cluster, any filament, any luminous node of 100,000 galaxies gathering in the darkness. That thought, let it settle into you like warmth, like the warmth of a bed on a cold night, like the warmth of a fire seen through a window, the warmth of belonging to something vast enough to hold everything. You belong to the cosmic web, and the cosmic web holds you, and now and always, tonight and every night, and in that holding, there is rest. Breathe in, slowly, and feel the air fill your lungs, feel the rise of your chest and the gentle expansion of your ribs, and breathe out, letting everything release, every tension, every thought, every plan, every worry, letting it all dissolve on the long, slow breath of an exhale. The stars are burning quietly overhead, their light falling on every surface of the earth and disappearing into the warmth of the world. The JWST orbits its distant Lagrange point, its mirrors cold and perfect, collecting the ancient light of a universe that has been sending it this way for billions of years, and the cosmic web spans the darkness, as it has for most of the age of the universe. Patient and vast and woven through with the slow movements of matter toward its eventual destinations. And you, here, now, are sinking slowly and beautifully into sleep. Your thoughts are becoming softer, less defined, like clouds dissolving in afternoon light, like galaxies at the very edge of detection, their forms uncertain, their light just barely reaching the threshold of visibility. The concepts we have explored tonight are not lost, they have settled into some deeper part of you, the part that keeps things without effort, the part that knows things without needing to articulate them. They are part of you now in the way that all the experiences of a day become part of you, absorbed, integrated, resting quietly in the deep stores of the mind. You know, in that quiet way, something about the web, something about its vast scale and its delicate filaments and its patient nodes and its immense, breathing voids, and that knowing is a gift, and you can hold it lightly, the way you hold all the best things, without grasping, without effort, simply there. The James Webb Space Telescope continues its work as you sleep, the universe continues to expand as you sleep, the galaxies continue their slow drift along the filaments of the web as you sleep, all of it patient, all of it continuing without any need for your attention, without requiring anything from you at all. You can truly, completely let go. There is nothing you need to do, nowhere you need to be, no thought you need to complete. The universe will manage its own affairs through the night, as it has for 14 billion years, and when you wake it will still be there, every bit as vast and intricate and beautiful as it is right now. And you will wake with some small portion of its beauty still present in you, still resonant in your cells and your thoughts and the quiet background hum of your awareness. But that is for tomorrow, for the morning light and the first slow thoughts of a new day. For now, there is only this, the darkness behind your eyes, the softness beneath your body, the rhythm of breath, the warmth. Let your mind go where it goes when it is released, let it follow the filaments of dream wherever they lead, let it find whatever peace it needs in whatever images and feelings rise from the depths of sleep. You are safe, you are held, you are part of the web, and the web is part of you, and between these two truths there is a space of perfect rest. The universe breathes, and you breathe with it. Slowly. In and out. The light from galaxies 14 billion light-years away is still traveling tonight, falling through the dark and empty space between here and there, carrying information about the youth of the universe, about the first filaments that formed when the cosmos was still finding its shape, and somewhere along the way, some small portion of that ancient light will strike the golden mirrors of JWST, and will be gathered there, and will be transformed into data, and the data will be transmitted back to Earth, and the scientists will look at it, and they will see something they have never seen before, and they will feel the quiet shock of discovery, the particular joy of understanding something new about the universe we all inhabit. And all of that will happen without your assistance, and all of it is possible because of the long, slow accumulation of human curiosity and effort and wonder that built the telescope and launched it and guides it and interprets its findings, and you are part of that too, in your way, by being someone who wonders, by being someone who takes time to contemplate the universe, by being someone who finds beauty in the knowledge that we are small creatures within an infinite web of matter and time and light. Your wondering matters, Your curiosity is part of the great project of understanding, and tonight you have added something to your own understanding, however softly and however gently, and now you can rest, as all good work deserves its rest. Sleep is coming now, you can feel it, that soft weight at the edges of awareness, that gentle blurring of the line between thought and dream, that sinking feeling that is nothing like falling because it is entirely safe and entirely welcome. Let it come, make no effort to hasten it and no effort to resist it, simply let the natural rhythm of your body do what it has done every night of your life, let it take you down into the deep and nourishing darkness of true sleep. The filaments of the cosmic web glow faintly in the far distances, the galaxy clusters pulse with their ancient heat, the voids expand in their slow and silent breathing, and all of this is so far away, and so vast, and so patient, that it asks nothing of you but to exist within it. And you do, effortlessly, beautifully, inevitably, you exist within the web as surely as the stars do, and like the stars, you will be here when the morning comes, burning a little lower but still present, still part of the pattern, still woven into the great and luminous structure that the universe has spent 14 billion years creating. Rest now. Rest in the web. Rest in the darkness between the filaments, which is not empty but full of the thin medium of space, full of dark matter moving in its silent currents, full of the faint radiation left over from the Big Bang, still traveling in every direction after all this time, the universe's first and oldest light. You are surrounded by that light, even in your sleep. It passes through the walls of your room and through your body without interaction, a ghost of the oldest event, a memory of the moment when the universe first became transparent and released its primordial brightness into the void. You swim in that ancient light as you sleep, an invisible ocean of cosmic memory in which you are always immersed, whether you know it or not. And knowing it, perhaps, makes the darkness a little warmer, makes the night a little more companionable, makes sleep a little more like an embrace. The universe holds you. The web is present. And you are drifting deeper and deeper into the soft and welcoming space where consciousness dissolves into dreams. Let your last waking thought be of the light of the ancient photons streaming from their distant sources, of the golden mirrors catching them after their long journey, of the images that result, showing us the architecture of everything. Let that light carry you now, not outward, but inward, into the deep interior spaces of sleep where the mind finds its rest and renewal, where the day's weight is lifted and the night's peace fills every corner. Deeper now. Softer. The breathing slows a little more. The body grows a little heavier, a little warmer, a little more completely at rest. The mind releases its last few thoughts like stars releasing the last of their fuel, gently, without effort, the light of consciousness dimming to its peaceful nighttime level. The cosmic web is out there in the dark. And you are in here in the dark. And the dark is the same dark. And in it, everything rests. Sleep. Sleep now. Gently and completely and without reservation. Sleep in the arms of the universe that made you and holds you and will always, in its patient and eternal way, be there when you wake. Sleep.